Hello everyone and welcome to this video where today in this lesson we're going to learn how does blockchain work. Okay, we're going to understand the inner workings of blockchain technology in this video. So first, let me give you an introduction on what blockchain is again. Blockchain technology has garnered significant attention for its potential to revolutionize various industries. To comprehend how blockchain works, it is essential to delve into its underlying mechanisms and processes. This video aims to provide an in-depth understanding of how blockchain operates, highlighting its key components and the steps involved in a typical blockchain transactions. Now, let's go forward and basically learn about the fundamentals of blockchain and how it works. At its core, blockchain is a decentralized and distributed ledger that records and verifies transactions in a very transparent and secure manner. It operates on a network of computers known as nodes, which collectively maintain the blockchain. Each node holds a copy of the entire blockchain, ensuring redundancy and resilience. Number 1. Data structure. The fundamental building block of a blockchain is the block. A block consists of a bundle of transactions along with a header that contains metadata and a reference to the previous block. Note this. These blocks are linked together in a linear and chronological fashion, forming a chain of blocks. Number 2. Consensus mechanism. Blockchain relies on consensus mechanisms to validate the agreed state of ledger. Consensus mechanism. Blockchain relies on a consensus mechanism to validate and agree upon the state of the ledger. Common consensus mechanisms include proof of work, POW, and proof of stake. In POW, participants known as miners compete to solve complex mathematical puzzles. The first miner to solve the puzzle adds the next block to the chain and is rewarded. POS or proof of stake, on the other hand, selects validators described or based on their ownership or stake in the blockchain. Number 3. Cryptographic security. Blockchain utilizes advanced cryptographic techniques to ensure the security and integrity of transactions. Each transaction is digitally signed using a private key, which can be verified using a corresponding public key. This cryptographic security prevents unauthorized alterations to data, ensuring that transactions remain tamper-proof. Now I will explain you the processes of a blockchain transaction. Okay, so now let's explore the typical steps involved in a blockchain transaction. Let's explore the typical steps involved in a blockchain transaction. Number 1. Initiating a transaction. A user initiates a transaction by creating a digital representation of their intent, such as transferring a specific amount of cryptocurrency to another user or executing a smart contract. Number 2. Transaction verification. Once initiated, the transaction is broadcasted to the network or nodes. Each node receives the transaction and verifies its validity by checking the digital signature, ensuring that the sender has the necessary funds or meets the conditions specified in a smart contract. Number 3. Block formation. Valid transactions are grouped together to form a block. Miners or validators compete to solve a complex mathematical puzzle, aiming to find a nonce, which is basically a random number that, when combined with the block's data, generates a hash value that satisfies a specific criteria. This process requires significant computational power and serves as a mechanism to prevent spam and fraudulent activities. Number 4. Consensus and block addition. Once a miner or validator discovers a valid nonce, the spelling of nonce is N-O-N-C-E, nonce, they broadcast the solved puzzle to the network. Other nodes verify the solution and, upon consensus, accept the block and add it to their respective copy of the blockchain. the new block is linked to the previous block through its header, creating an unbroken chain of transactions. Number 5. Blockchain confirmation. As subsequent blocks are added to the blockchain, the transaction becomes more secure. The more blocks added, the more difficult it becomes to alter or reverse a transaction, providing higher level of trust and immutability. Number 6. Transaction finality. Once a transaction is included in a block and added to the blockchain, it achieves finality. The transaction is confirmed and cannot be reversed without consensus from a significant majority of the network. Okay? Now, I will basically give you an elaboration on the blockchain inner workings right now. Now, there are more elaborate explanations of the inner workings of blockchain technology. First one is decentralization and consensus. Blockchain's decentralized nature is a cornerstone of its operation. Instead of relying on a central authority, the blockchain network is composed of multiple nodes distributed across the globe. Each node has a copy of the entire blockchain, ensuring redundancy and eliminating the risk of a single point of failure. Consensus mechanisms play a crucial role in maintaining the integrity and agreement among nodes. They ensure that all participants on the network reach a consensus on the validity of transactions and the order in which they're added to the blockchain. The most common consensus mechanisms are proof of work and proof of stake, as I clearly explained before. In the proof of work system, miners compete to solve mathematical puzzles, and POS, on the other hand, selects validators based on their ownership or stake in the blockchain. Validators are chosen to create and validate blocks based on the proportion of cryptocurrency they hold. This mechanism aims to reduce energy consumption associated with POW while maintaining network security and consensus. Additionally, cryptographic security is where blockchain utilizes advanced cryptographic techniques to ensure the security and integrity of transactions. Each transaction is digitally used and signed by a private key, which provides proof of authenticity and ownership. The digital signature can be verified using the corresponding public key, ensuring that only the authorized user can initiate transactions. Additionally, cryptographic hash functions are used to generate unique identifiers or hash values for each block on the blockchain. These hash values are generated by processing the block's data through the hash function. These hash values are generated by processing the block's data through each of the hash functions. Any modifications to the block's data would result in a different hash value, meaning it would be nearly impossible to tamper the data without detection. This cryptographic security combined with the consensus mechanism ensures immutability of transactions. Once each transaction is added to a block and included in the blockchain, it becomes extremely difficult to alter or reverse it. A subsequent block are added to the chain, the transaction achieves greater security and becomes more resistant to tampering, providing a high level of trust and reliability. Okay, that was all for this video. I hope you've understood what is blockchain. So thank you for watching.